think.
Okay.
Uh,
Today, go ahead.
Sorry,
Any question?
Siomak. I think Siomak microphone is off.
Or do you have the questions, Yamak?
Yeah, we cannot hear him.
Okay, sorry. I
You
mean, I was
Yeah,
you
mute.
mute, yeah.
Yeah, no, my Skynet email came like 3 days ago, so I just figured it out. I just saw it tonight. Sorry, I didn't take any picture.
Okay, that's good. That's you're gonna start the enjoyment
Yeah,
shortly, but hopefully you get to review the material and get access closely.
and
Thank you.
if it is full moon, I mean, I really don't take picture. I just take a wine and then go start reading some poetry. But
Uh,
other than full moon, I take pictures. I will do that. Sorry, it
That's
was a
good.
joke.
That's good. That's good. Let me share you some material on the screen beginning of the items that we had. Okay. Uh, Today we had an excitement news that is based on the uh, what do you call it? Probably you see it in my screen right now.
Yep, yep.
Yeah,
yeah.
it is International Day of the Women and Girls in Astronomy, and that's a very celebrated time of the day that we value the forgotten kind of consideration that along the history of the humankind, the women and girls happening on this era. This website that I'm gonna share it with you is kind of a procedure for outreach that AIU, International Astronomical Union, provided. And there is a specific game here is created, Women in Astronomy card game, that each of them it create kind of information about the important women and girls in the story that is developed during the history of the kind. And astronomy as well. And these each of them provided very brief description of all of those women from the early about 2500 before till now. And therefore, this is kind of things that I would not like to, in the initial, in the start of this session, to inform you. And if you're interested, have a look through it and inform activities about this activity. Let me share it to you again, this link for you. I will put it on the chat.
Mhm.
Okay, then we go to our actual course and session tonight. Okay, the material that we had on the web assign is we discussed it last week about the different telescopes and different procedure how to go over and look through the instructions and the material that he had. And then the next one that we are going to look through here is procedure. When you take the uh, actually pictures, well, how you're gonna do with the material you're taking. The item that we had it, for example, in Skynet, if we go to the observation here, I take some pictures that a kind of sample to gonna show you how we're gonna work on those. One of the items that I gonna mention based on the Farhad question is that, for example, when you had the new observation, you see the sky in here based on the material that you wanna see, and when you change the hours, it's gonna change the direction. Let me put the coordinate as well here. You see, here is the daytime. When it goes to night, when sun sets here, when you see the sun, you don't see anything because when you have a sun, you cannot see anything. But after sun sets, you can see many different things here. Therefore, here, one option that you can specify target here, whatever you have. For example, I will give you another example, Jupiter, and search. And it finds the Jupiter with this mark. You see this orange circle with the plus sign inside it. And it put directly, you can choose the name, different name here, but the coordinate of the system, right extension, and the declination is given here. And then here, the item that was talking about the moon separation is here. Normally, program itself directly choose the 30-degree minimum moon separation. It means that what target you're choosing here has to be minimum 30 degree to able to take a picture. Therefore, this is already assigned to the program. Therefore, when you go and finish your observation, you specify filter, telescope, and exposure and review and submit. When you do that, it's gonna choose based on that 30-degree separation. It means that if the object is less than 30 degree from the moon, the picture not gonna take and gonna wait for another time. It's gonna go over, for example, this is the next 24 hours only, but after 24 hours, that this graph's gonna change, and the picture is gonna taking when this is 30. If you wanna make it more better, you can change it to the 60 degree. Then you do it accordingly. Or you wanna take a picture of the moon. If you wanna take a picture of the moon, you have to put 0 here, because when you're taking the moon, moon is object has to be 0, because otherwise you cannot catch it and program gives you error. This is only kind of, I think, hopeful for your question, the one that you had raised minutes ago. And then we go back to the observation that we have here. Let me go some example. One of the example that we had it here, like for example, I will take M104. When you click, before going that, you see whenever you submit, it is active. It means that the picture is not taking. By asking for the Neptune moons here is active, is not taking. Or the others that is active is still waiting to proper time and possible solution to take a picture. But whenever it's complete, the picture is taking. I choose the MO4 here. And when you see the next page here, there is different type of the picture normally taking. There is bias, dark, and flat. This is kind of pictures that is taken by the telescope to make adjustment for the correction of the photography. You don't worry about any of those, but if you want us excited to see what those are, for example, dark picture, you see the dark picture, you see it is not very dark. You see layers of the right uh, fade or paints here, glow here. Therefore, it means that there is some issue on the telescope axis because of this dark picture and also the other bias and the flat. It adjusts the picture as needed to make it. This all of them is done by the program Skynet. You don't need to worry. Only thing that you needed to take is the one that is here showing by download GPJ. And when you click on that, it shows you the picture. It sounds very good and good picture that shows here, but sometimes you see it, the orientation may not be correct. That is dependent on the lenses and the devices that you have on the telescope. The next thing that you're gonna do for the post-processing, you're gonna go click AfterGlow, open AfterGlow. When you click open AfterGlow, it brings another page. Sometimes it takes time, and sometimes you have to wait for another minute or so comes. And then here you can assign a new signing name for yourself, or easiest way, just log in with the same user ID and password that you have on a Skynet. When you click here, it bring it here. In the middle, on this page, you don't see it anything on the middle because you didn't choose it anything here. Then the only option that several options you have it here. When you want to open the file picture that you're taking, you don't need it to download the picture. For example, the picture that you have it here, You don't need to download on your computer and bring it back here. Everything is on web base. It means that it is on Skynet database, taking for you, and you taking those, and you have to ask them to bring it back for you. The option that you see it here is open file. The next one is the save file, close files, or refresh the file list. Sometimes you need it to refresh if something goes bad here. Therefore, I click here, open files. When I click here, open files, I see three directory here. Sample, Skynet Robotic Telescope Network, Web Workspace. And there is another option here is files. If you want to choose separate files on that you save it somewhere, you can do that. This one, you choose it accordingly. But here, the sample file that you have it here is the sample file is provided some sample pictures that taking. You can go over and look through them. And those is, for example, this is a picture from JWS that taking. For example, you can look through it. Sometimes it takes time to, when you click it, you bring it back. It takes time.
What is JWS?
James
Uh,
Webb.
James
James Webb, okay.
W. Webb. Yeah, James W. Webb Telescope. That is, let me see. Sometimes it takes time or take it. Let me close this one, cancel. Do it another thing. Go to the again here. Go back here, files. Okay, this is, as I mentioned, the samples. You can go through it and look through it. Some of them is very big because it's taking, let me go to the sample for the solar system, moon. Let me see if it's, yeah, it's successful. Here, as you see it here on the middle, it's a kind of a system that you can see the on the page, the picture. You can do bring it zoom to fit or zoom to reset or bring it here, little bit zoom out or zoom in. This picture is only shows a very corner side of the moon only. And this one, reset the zoom, zoom fit, zoom out or zoom in. And there is two other options here exist. One of them is the download. When you click this one, it saves the picture that you have taken here on the download system in your computer. The next one that is more kind of more applicable is save it, export it as a JPG picture. When you do that, again, and bring it here and save it moon here, and then you can open it after downloading. For example, here, you go to and this is another picture of the moon here. Therefore, this is kind of very simple way of the how you're working with these applications. And therefore, this is a kind of common set of the file that you have it here. And you can enlarge it, this, play with it, bring it right or bring it left, and then zoom it and bring it, adjust it, the location of the picture here as needed. And sometime this on the right side, you see several items is important. This is a graph of the light that is seeing for the picture that is choosing here. And there is many different objects exist that I'm going to show you later on this course on the next week or so. Several items on the right side, you see it. This is a high display. It's this area, display area on the right. You can hide it. You show it only picture, or you bring it back. The next one is the eye. It shows the uh, file information, what the size of the file is, how many pixel the size, and field of the view about 1.4 degree, and what time it started taking picture, and what's the center time, and what observatory taking the picture, and what telescope. This is a prompt, Saskatchewan and Canada, they take this picture. And what filter used, and the exposure length was how many seconds, 0.2 second. And that's a very basic general view of the information that you have. You can change it those as needed. For example, here you show it as a kind of raw data or system data and other options. The next item is the uh, important one that we have. This is kind of a specific for the plotting the graphs that we're using. And also another thing is here we're gonna go through those in the next sessions, but most important item is that hide and display and the information and also the graph. This is three items that we mostly be using those cases. Let me go back another thing. If we click, you see on the next item, I choose it, this one. I go back to the files. I go to the, if you want to look through your own files, either you have to come here, specify the files, or you just click on the workplace. In the workplace that you click it, it's going to show you the files that you already specified in your Skynet that you're taking. And therefore you can click it in any of them and bring it back on the screen for a second. Let me see if I bring it, enlarge it a little bit. Go back again. Do it again. Okay. Let me do it this way. Sometimes the access to the data a little bit difficult to do that, but let me go show you another thing here. New directory. Okay, go to the
What is extension of dot fits?
Fits normally is one of the we have several different type of the files we have. JPG is very famous, or PNG that we're using in normal photography, but fits is a kind of a specific kind of files that we're using for the astrophotography, and also another one is a RAW that we may use it. But I will tell you, that's a good question that you wrote it here. Let me go to the another picture that I save it here to show you white box. Here is the Jupiter's moons I taking. Let me see here. When you click first, you don't see it anything because probably it's just zooming only a small portion of the picture. But when you say zoom to fit, it bring it back here. Then this is kind of, let me go back to the Skynet to ask the question here. The one that you normally have it here in this area, when you take a picture, normally it shows you the uh, different, for example, each one of them you're choosing here. This one is the JPG, and this is FITS file. This is actually FITS file that is has many data on it compared to the JPG, and has a kind of better for the astrophotography. Most of the time we're using this one, and also you see it on here. Also we bring in fits as well, but you don't need it to click and bring it back download here. This program itself, it took it directly from Skynet, whatever you have it here. Another one is the view header. This one, when you click here, it gives you many data that is embedded inside the this picture that is taking. Most of them, some of them, for example, is specific for the different technology or code. For example, this one, right extension and declination of the object that is taking, and also various different things. But we don't want to worry about those. Mostly, we just using with JPG and fits using directly in here. I
If I
hope
could
you
speak,
get the question.
if I go just a little bit into that, since you asked a couple
Go ahead.
things. One way to think about the fits is PNG is compressed, meaning somebody's taken all the data and has come up with an algorithm to save memory. PNG is compressed, but not as bad. And then you have like GIFs, which are compressed. You never use a GIF. A FITS file is everything. There's no compression on the image. It's as good as you get. Plus, the header that Abbas was showing you, it is in there also. And that's a layer that's underneath the image. And it has everything you'd ever want to know about the image that was taken, and then some. So even what kind of filter they use on the image, how big is the camera? I mean, they put everything they want to think about that you might ever want to know to correct or fix an image as a hidden feature, that header inside the FITS files. So when we want the best data, we want to really check things out, we stay with the FITS. Otherwise, you're compressing it. Although the PNGs, I think, are nice when you want to print something out. You want to save something out, you'll kick it out in a high-sized, high-resolution PNG to print, because the FITS will take a crazy amount of memory. And I've done this with a class where I've had 20 students try to all use the internet to upload FITS files, and we just about crashed the whole school system. I mean, they can be pretty good sized files. Just kind of realize that. There's my
The question is so in the when Abbas was showing, so in the header file there was a latitude and longitude in radian. Is it the location of the telescope?
It'll tell you everything,
Okay.
including
Everything is
the
there.
location
Everything.
of what your object is and right ascension declination, how big of a
Okay.
field. I mean, it tells you, it's got everything in there.
Thank you.
Yeah.
And the pictures that Abbas was showing were after glow or before glow?
After, yeah, this one is the one that you see it here. The one that I showed to you here, when you click here on the Skynet, you see it from the Skynet. If it is come, you see here, it takes time to bring it. But this
Okay.
one is a Skynet. When you click it in here, when you are on the Skynet web page. But when you go and click Afterglow, you go next page on the Afterglow here. Therefore, you see here in the left, upper left, it shows Afterglow Workbench. This is a specific program is written by the university to take a picture and process them as needed.
So what's the difference between, so the one that you showed before was much more clear compared to this one. So afterglow is less clear?
I'm gonna go over on
Okay.
this one. Yeah. If you see it here, as I mentioned, this one it shows the graph here. This graph, it's when you see it in here, three icons. You may use it very often. This is when you click this one, you see it kind of this is for the faint target. When it is the object is very dim and faint, you're using this one, and this is the default that normally when you upload it here, it comes the default. And when you want to see the bright target like planets, you click this one. When you click the bright, you see that the Jupiter, I zoom it in and locate it on the center. It is like this, and that's the way that you're gonna see it. But when you click this one, you don't see it moon anymore. Therefore, you have to adjust the saturation here accordingly to reduce it a little bit. When you make it 100, no moon is available, but you have to decrease it the saturation. You see, I will do it. When you decrease the saturation, the planet become blurry. It's not very visible. But at this investigation, we don't worry about that. Let me make it zoom out a little bit. Still, we don't see any moons. I have to bring it down. Yeah, yeah. Let me zoom it out to show you again. Again, I go to bright, reduce it the saturation. The planet become blurry, and again, immediately when the planet moons are observable like this, it is the best thing that we can start our measurement and observation. The good thing on here is that when we go to the when we check the location of the object here, when we go to the show plotter, on the show plotter, there is a two option here, centroid click, interpolate pixel, and this is kind of option that it creates kind of for the measurement tools. Normally, I recommend to use always the mouse. Try to not use with finger to locate the mouse on the screen because that's going to be very difficult. Always, we recommend to use the mouse for this purpose. For example, if I want to decide the distance between center of the planet Jupiter with the first moon, then I click here, bring it on the here. Because when we said here centroid click, it means when it clicks, the program itself choose the best location as a representative of the center of the moon and the planet. Therefore, here it gives this is a plot of the light curve, and here we have a light high luminosity, and here we have a darkness, and gradually here this small bump here is the brightness of the moon. As you see it here below, it shows also the length. The length that you have it here is about 226 pixels or 90 arc seconds. That is measured here. Therefore, this kind of information is available on this kind of option on the height plotter, and you can use it as needed. Another important thing is that sometimes, as I mentioned last, I recommend to use one of the program, we call it Stellarium. That when you go to the Stellarium and check the location of let me go over here at the moment here, see it, it is 17 of the September 2024 at 7:45 Greenwich Meridian time. For here, I recommend to use this is a kind of web page, but I recommend to use whatever we have on the uh, web page downloaded. The reason is that when you use the one downloaded Stellarium, it's gonna give you more information about this data. Do you see it the screen? Let me share it again. Probably it's missed it. When you see the Stellarium on the web page, as here, you can look through the things I'm gonna show you here. Then, for example, you bring the Jupiter, you specify zoom it in. In here, although this is different time, as you see, it's also moving because the time is moving here. But when you see the orientation of the different moons and names, you can identify here. Therefore, we're going to use it later on this course to compare our picture with the proper time that we have according with that, and also bring back the actual view of the workbench that we have it here. Here, we can identify which moons are here and what's the distance between them. And on the next weeks, we're going to look through it. But the bottom line is that the one that I showed to you here to identify information about the Jupiter that we can grab it based on the comparison with the what you call it, the um, Stellarium here. And if sometime needed, we needed to flip the picture because, you know, sometimes when you take a picture from telescope, it's upside down or flipped. We have option here that we can flip it. For example, flip it up and down, mirror it left and right. And we have to do combining set of this to make sure that our orientation match with the one that we see it with Stellarium. Or sometimes you need it to rotate. Uh, there is a three option exists here that you can maneuver with the orientation of the moons and Jupiter or object. You can see it accordingly. That's a kind of basic operation. You can do it based on the pictures that you're taking from the AfterGlow. Any question on this so
Just
far?
one question. Between this picture, the one that you just showed, and the one that actually was processed, you only see the planet. That looks very luxury. You see all of those. You might even see the hurricane inside the Jupiter. But so this kind of zooming happens. What kind of filters is it? It's like based on fast Fourier transform. And then how do you do the moons? Can you do the same filter on the moons and see the moons as good as you could see the planet?
Well, this is kind of things that I mentioned earlier. This one, this filter that we specified U, for example, we specify U for the Jupiter and B for the moons and Jupiter. Therefore, we use different filter when we want to see the moons. Yes, that's correct.
Yeah.
But we don't want to see like a very fancy luxury picture like we see it on the social media, on the Facebook or others. The reason is that we are taking the picture from the Earth. Those fancy pictures are very well processed and probably taken for by the spacecraft near the planets. Therefore, you don't expect to have very nice, colorful picture. The only gonna see it on this sessions gonna be white and black, and that's it, or gray, and not gonna be very colorful. There is another course after this, gonna be they call it the MWU or multi-wave universe. That on that course, it's gonna show we're gonna show how to color the pictures, but again, that's not gonna be fancy like the one that is on the Facebook because those is completely different things. But the one that we have it in this session and next on that MWU that I said, it is based on the actual scientific work and the investigation that all the scientists do, and we can get enough information for process as needed.
Thanks.
If I could
Any
share,
other question?
can I share my screen real quick, Abbas, and kind of
Oh,
continue
go
on?
ahead, go ahead, go ahead.
Yeah, I don't know if I get the right one open. Let's see. It's gonna
Let me
share.
see. I say,
Is
yeah.
that up?
Oh, it's
Can you see
opening.
that
Yeah, yeah,
okay?
yeah. Go
Okay.
ahead.
So this is in Skyview, and Abbas is spot on. I mean, Hubble, phenomenal images, and James Webb, the new one's going to get some really incredible. We can't get so much ground based, but a lot of this as we're doing it, take notes as you go through, and let's share with each other what's working. Here, this is an image. I did grab Venus, and I don't see anything, but I do change it to bright target, and then it pops out. And I'll show you a couple little tricks. I'm gonna go ahead and increase my saturation here as much as I can. And it still looks like it's not like something in a magazine, I mean, it's overblown, a little blurred. And that's where when we learn how to use these features off to the right, like if I look at the show plotter here, I drew a line across it. And this allows us to get an idea of how good of an image I got here. All right, so what I see here is if I take this little doohickey here and I see if I can do that again. No crud, we're doing so well. There we go. I'm gonna draw a line across here, and you see how this is pegged off at the top? It looks like a little hat. Yeah, it shouldn't look like a hat. This doesn't look like something that's gonna be so sharp because I've overshot this. And so when we go through those settings to take this image, I just learned that whatever exposure time I put in this, like 0.03, it was too much. I'm gonna try to do 0.02 something, and I'll try another shot and see what happens. And I want to share that out. If I get an exposure that works really good, I'll let you know. Because if I scroll down here, you see I get to the edge, this starts to go from a hat to, it actually has, look at that. You know what I mean? Now it's a pointy thing. This looks like I haven't lost any data. So as we're going through this, a lot of this is going to be trial and error as we do this, and just learning from each other, because that's actually what I'd like to see when I'm going straight across the middle. And that image is going to look a whole lot sharper, a lot more detail, because I'm not going to get any surface features. If Mars looked like this hat, I'm not going to get any polar ice caps. I'm not going to get anything in the image. I'm just got a big blur of white is what I'll get. Now for Jupiter, if we're looking for the moons, this might be ideal, because I don't care if Jupiter's bloomed out. I want to catch the really faint objects, which are the moons. And so I'm going to use a longer exposure time so that when Jupiter blooms, gets too bright, I can see the other things. And a lot of this is just going to be practice and trial and error when we go through this.
So one
Does
question
that help?
actually on this. So why saturation is a problem? I mean, the x-axis is just a distance, correct? And then why saturation is a problem? Why do you expect a peak?
So this is like, all right, so we have a CCD, which is a whole bunch of little detectors. That whole picture is a whole bunch of little picture cells picking up light. If those wells, each of those little pixels has a well, and if that well gets completely filled up, the old ones used to spill over and just blur the whole image out. These they peg out, they max out. And when they max out, you lose all of your detail.
So it's a resolution problem.
Yeah, it's just my exposure time was too long. I don't want that. So I will take another image. I'm glad I got Venus before it's, well, I can. And I still want to get a couple other planets, but I'm going to next time. I'm going to try less. I'll let you know I did use 0.03 as was suggested. I would recommend to you, if you want a sharper image of Venus, try a little less time. And I'll try to share out what telescopes I was using. I think this might have been, well, I'll have to look. I'll see which ones I had that gave me this bloomed out image.
And then the shape. This is Venus, you said.
Yeah, this is Venus. Beautiful
Okay.
phase. If that's what I wanted to see, was I just want to see phase, I captured it. If I want to see a little more detail, yeah, I need a little shorter exposure time.
But with our own eyes, we never see like phase like this. We always see a circle, correct? I mean, our eyes shows a circle, but that's
Well, let's
just
go
a
with
mistake.
pair of binoculars or a telescope. You'll see this.
I see. I see. I thought it's moon, but yeah, it is Venus. Yes, yes.
No, it is one of the planets that they can see at the phase is Venus, and it is very bright and very good, but through the telescope only and bino. But from bino it's a little bit difficult, but from the telescope you can see it easily, and it's gonna be very good.
Interesting. Yeah.
Uh, Thank you, John. Do you want to share something else also?
Oh, actually, my mic's still on, so I can talk. A couple little things about Stellarium I try to share each time, little things I've learned. One is with Stellarium, you have the web version, which is very nice. And then you also have the download version. And the web version is very limited. That can be very handy if you don't need much. The downloaded version is much more robust, and it's almost too much stuff. Be careful on how much stuff you download. It has a lot of add-ons. If you add on everything it has, you're going to have a huge file on your computer. And if your computer can handle it, I guess that's great, but it still is too much information unless you're looking at magnitude 18 objects, which are incredibly faint. It doesn't make sense to do that. So be kind of careful with that. I might share my screen one more time because I'm going back to what we talked about with since we talked about Mars, that was an awesome point to make. But I'm using the web version of Stellarium. So when I click down here in the right corner, it gives me this time device down here, which has the year, the month, the day, and then I can affect the time. And when you use Stellarium, do make sure you go into your settings and set it for your local location. I know I've used this in the past, and like I'm viewing from South Dakota, and I didn't know, like, oh, wait a minute, it doesn't look right. Or from South America or somewhere else where you don't want to be. So make sure you do your setting. But this allows me to real easily see that if I go back to the 9th, you can see right there it is. There's the moon and Mars next to each other. And then if I click it, there's a 15 degrees or 1 hour separation. That's the width of your hand in the sky. And if I do another one, we'll see there's 30 and 45, and it's moving on across. And you can kind of see how everything is slowly rotating across the sky, left to right, east to west, except for the moon, which is each night, it moves on average the other direction. This also is really nice because we can see where Venus is really close to the horizon. Saturn is down. And if I zoom in on this, Uranus is still out here. Good object to get, but Neptune is, again, really close. So I'm going to probably try to get some of these objects closer to the horizon and try another shot at Venus with a lower exposure time and see if I can do a little better. Hope that was helpful.
So one question. So to set up that, if I'm looking from Chicago, how do I change my setup to go to the Chicago as an observer?
So I'm going to go, that is not it. I think it's top right. That's not it either. Okay. Somebody else want to weigh in on that?
The desktop version of Stellarium and the web version are different.
Yeah.
There is a location setting that you can use on the desktop variant. I don't remember the exact position of it. I'd have to open it. It's on the left side, and it's a particular setting that you have to go to. And you can change your location by either clicking on a map or you can set your geocoordinates, whatever that may be. I think John just found it actually.
Little tab on the bottom left right here. I'm hitting that and it'll do auto locate. So I like to
I
use
see.
or pull you in.
I see. Got it. Thanks.
Desktop is completely different. Like Christian said, it's a different location. It's in the settings.
Yeah.
When you go to the left, a whole menu pops up. It's a weird app. And along there's a few options, and one of those allow you to set your location.
And then this view, John, is a simulation, correct? That's not a telescope. You're not seeing anything, correct? You just see a simulation.
Yeah, it's a
That's
simulation.
right.
It's a really good one.
Okay. Okay.
It's free.
That is very good for the scientific observation, and also most of the observation picture that we're taking, we're comparing with the stellarium. It's very well developed and very accurate for the or practical purposes.
Okay. Good. Good. Thanks.
And also very good if you want to observe something in the sky and see it for tonight, what you have it. It's very good tool and also free. And you can do it from your cell phone or any place
Excuse
in
me,
your computer. Go ahead.
this for Stellarium, I just downloaded before, and there is different type of the Stellarium, as John said. But which one, in this one that you have, which one is that? Because there is different version or different type or something. Like exactly which version is better to download? It's not only one, correct?
Yeah, well, on the online download, it'll be specific to your computer
Okay.
because it'll do a Mac, PC, or it'll do I don't know if it does Linux or not, but it does a lot of different versions of it.
Okay, yeah. I mean that because the version I remember it was different version. The latest version we should download. Right?
Correct.
Yeah, and it'll give
And
you
let me show you. Yeah, let me show you here. That might be helpful. You see, when you click the Stellarium, when you check the Stellarium on Google, you see one of them is a web based, and we're looking for the software, the Stellarium software. When you click this one, you see various options here. This is based on the Unix operating system. This is a Mac. On the Mac only we have one version. And the
this one, I
Windows,
mean, yeah.
yeah, Windows 32, Windows 64. There is a 264 Windows and one the web. Therefore, based on your whatever operating system and computer you have, when you're choosing the one, that's the only version that you have. But then it changes. Here you see it different versions on the news. Right now, probably is 24.4 is the latest. And then this is the bottom line, different version there is a here. But normally the one that here 24, this is latest one, it's always showing on the top. Therefore, choose from those and don't go to those because those may have different things, but this is updated one based on the current computer system that we have on the market.
Thank you.
You're welcome. And the another thing, the one I want to show it to you, another item. Let me open it here.
And Christian, I would just honor your question on the side. You're asking about getting the files from Skynet to AfterGlow. And, you know, I've hotspotted this and made that happen. I don't really know the answer to your question.
I'm only wondering because if we're dealing with FITS files, of course, they're going to be huge. And so I don't know if it's in a cloud, so if it just transfers over to AfterGlow, if you can just access it freely, or if you have to download it and then upload it to AfterGlow. You know what I mean?
I don't think it downloads. You know, it's not taxing my computer at all. My computer's pretty fast, but I've used the school computer to do this, and they're not fast, and it has no problem. So I'm thinking everything's kind of virtual until you download it.
Okay.
Let me show you one thing here. I wanna just very shortly about the item that we discussed about the solarium and the observation. As you see it on the or Earth is located on the center or on celestial sphere on the top.
Actually,
Normally,
we are not seeing it.
you can
Oh,
see
yeah, yeah, we see it. Yeah.
do it again. Okay.
I think yeah.
You see it right now, yeah?
Yep, yep.
Okay. Here, as you see it on this picture, Earth is on the center and the celestial sphere, it is very large imaginary sphere that is all the star is embedded on it. This is kind of way that we normally use it. And the one that you see it on here with the green, it shows the ecliptic or the location that planets or solar system, sun and planets are located. It's not all of them on the one line. Some of them it goes up, some of them goes down. And that's kind of create a kind of system for us to create a coordinate system for our consideration. Due to that condition, if we look through it, and here, let me show it to you. This is a very good graph that shows us the things. This is kind of observation that regularly when we see it on the sphere and the circular, it might be a different view. But this is one of the traditional way that we seeing the picture or the map of the earth or countries on the globe. This is kind of location of the celestial equator or kind of extension of the equator on the earth. And this red line that you see it is the location that is ecliptic or moving planet and the sun is located. Whenever it's a location that is the celestial equator uh, meet with the ecliptic, as I mentioned, the solar system, plane of the solar system. And this is plane of the sky, the celestial equator.
Excuse
When
me,
they,
Abbas, can you just a bit scroll up?
sure,
We don't have both of them.
okay, let's see.
Yeah, we see the top one. John is on mute.
Yeah, we only see the top one.
Let
Yeah.
me do it the other way. Again, share it.
Yeah, you just need to scroll down on the page.
Oh, okay, no problem. Let me see if
Oh,
I can. It's better?
yeah.
Yeah, this is the graph. Yeah.
You see it, the graph better right now?
Yep, yep, yep. We see that.
Okay. Here, the blue one is the equator of the sky. And I will say this one is the plane of the moving part of the planet and solar system, red one. And the place that is blue and yellow is contacting each other is the location of the vernal equinoxes. This one is the vernal equinox or the spring equinox. This is a fall equinox. And the one that is on the top portion is the winter and solar solstice. Therefore, when on the northern hemisphere we are, on the north, the elevation of the sun compared to the uh, equator is highest, and also on the winter is lowest. And because of that, we have angle of the rotation that we're going to show it on the next week. But I'm going to give some indication for you that how this going to move it and this coordinate how it looks on the map. But actually, the one that we have it on the consideration of the, hopefully you see it, this one also, this picture that I showed before. And this one, it gives indication about the location of the sky. When we go to the Skynet to add the new observation, this similar to that one, this picture in the globe of the celestial sphere is the same as the one that we see it on the picture as I showed you before. Therefore, a little bit very difficult to imagine, but always you have to keep in mind that when you see the picture on the 2D, transfer it to 3D is going to be very difficult on the beginning. Sometimes it takes a few weeks to adopt it and adjust it. Sometimes it takes a few months. But as more and more you just try to observe it on the sky and compare it with the one that you see it on a stellarium and also on the graphs that you see it on the course, it's gonna help you out to imagine the location of the different object. As Farhad mentioned, this object gonna move. If you look through it from tonight to the next day, it's gonna be moved quite a bit. And therefore, that movement, it's gonna be, if you keep track of those either on the stellarium or sky, you can see it how it's gonna move, and you can make a sense of the moving object on the sky. That's what
So
I
I
will
couldn't understand.
share you. Go ahead.
Sorry, I couldn't understand that chart. The sinusoidal one, the red one, and the blue one. I mean, for me, because I don't know the coordinates what you're talking. So one of them is because of the axis of the Earth. It's different. So that so that so that what was called.
Exactly. That's the one that you see it because when let me show it to you the other way. This might probably is better. When you see it, the globe like this on my hand here, this is a what you call it, equator that you're considering
Mhm.
compared to that one. But the one that is orientation of the Earth is a little bit an angle. Therefore, it is moves in angle. Because of that, the red item that you see it has an angle here. This
Mm.
one is because of the Earth axis compared to the global celestial
see.
equator has about 23.5 degree difference. And you see it here from here to this point and here to this point is about 23.5 degree away from that. And that is because of the Earth axis, because Earth axis is not aligned directly with the orientation. That this,
Sorry, I think I understood. Yep, I
yeah,
see what you're saying.
this picture shows, I think, better. Let me bring it back
Why
to
they
me.
call it ecliptical? What does ecliptical mean?
Uh,
I know
just
what is elliptical mean, but what is ecliptical?
let me give it a
So
second.
as he's pulling that up, there's a couple terms we always have trouble with. One is the ecliptic, is like somebody just made that up. But that is that line looking straight out. So if you're at the equator, it's directly overhead. Where we're at, it's a bit of an angle. Somebody came up with the word ecliptic, and I'd love to learn why it is. The other one I have trouble with is right ascension. And the right ascension is what we use for the time going across. And it is this, like the sun does ascend towards the right, and I guess that kind of makes sense, but it seems like we could have came up with a better name.
Okay.
But that ecliptic is our bullseye. It's from the east up to where it's going to go straight overhead to the west. And you'll notice that if like you pull up, I'm going to go ahead and share real quick here.
Oh, that's called right ascension. Okay, I just
Right
saw
ascension.
it.
Yeah, somebody came up with this, but you see, I put the lines on here for the ecliptic, and if I run the clock forward, you'll see that everything's moving right across around that ecliptic. That's the path that everything's taking. So right here is 0 degrees, and our planets will tend to go above and below that line. Right now, everybody's above, but even the sun will be along the moon. Everything will kind of travel along that ecliptic line from east to west. I'm at Charlotte. We're pretty close to the equator, and everything's very steep. When I was back in Indiana, everything was a lot lower. And if you're at the North Pole, I mean, it's all the way down. Everything is right down there. And that's kind of that's our reference point in time. Because if I set my telescope like on Betelgeuse here, and I let the time go forward 1 hour, that wasn't an hour, was it? No, that didn't seem right. But if I go forward an hour, it'll be on the next line forward. It'll rotate right around that point. And for like taking pictures in these telescopes work, they can just set the declination, and then they go to the time of day basically for that object, and it's right there every night. That makes sense?
Yeah, I have one question. I mean, sorry, I know I don't have to.
Awesome.
This something is always bothering me because when I go back to the history, I know Newton was looking at multi-body problems, and he was going crazy that why Jupiter's basically orbit is not. There was some sort of basically it was tagging because of the sun effect. So there was some gravitational effect of sun and earth and moon. So he couldn't. So and I heard that. So it's like a initial value problem. If you don't know exactly where it is because of the multi-body issues, So how this simulation works that they could get this thing accurate? If there are several bodies and sitting there, how do they? Because it's not only it's a gravity model, but how do they do this kind of initial value problem that one of them is a little bit off, is going to get off more and more and more and more, and then it comes back in term again. It just oscillates, correct?
Yeah, it's amazing. And you can actually go back a couple thousand years. This thing seems to be spot on still with where things are. It's algorithms and it's just layers. I know when these
Okay.
SAR programs first came out, years ago, they weren't nearly this good, and you really couldn't trust them as far out. Stellarium is just, I think, pretty amazing on how precise it is.
And this
And
is based on solving these equations like Lagrange and all of this
Yeah.
stuff. They do all of these things. Okay, I see. Good, very
The
good.
one nice thing though for us and our planets is, getting a little physics here, is that really the central body will affect everything's motion. For all our planets, the sun is just so massive. Jupiter's the next thing, and it's 1,000 times smaller, right? So the sun dominates the equation. Jupiter doesn't change it too much. And the distance between these things are so huge that the interference between it just so
Second
small.
order. It becomes
Yeah.
second order. Okay, got it. Thanks.
Yeah.
Yep. Appreciate it.
Good
And
question.
also thank you, John, and thank you, question, Siamak. Let me show you one thing probably that help you. And also back to your question, ecliptic. The reason that they call it ecliptic in Latin, because that is pass of the eclipses. Solar and lunar eclipse happen at that around that region. That's the reason that they call it ecliptic. That's kind of a reason for that. This is a kind of very simple. It shows this is Earth, this is a celestial sphere that in the old days they're using. And our Earth is moving around his axis, but our axis is not like this vertical. It is on line. Like, for example, if you consider our axis here, the celestial sphere and our axis is going to be aligned differently. Because of that, it creates this
Yep.
graph that you see it
sinusoidal
here.
motion.
And
Got it.
that's one of the key things. If you are, for example, one individual sitting on the earth, he or she can see only horizon, like this line, above this line. And therefore, we just transferred this one to shape like this to make it our observation simpler. And then whatever you see it on our top of our head is zenith, and this is a meridian. And this one, the things that it shows the movement of the what we call object on the sky. And that's kind of, for example, if this is the equator that you see it, and this is the North Pole. This angle is dependent on the location that we see it. Always it shows the latitude of the place that we are. And for example, here we are on the Charlotte, is about 35-degree this angle. If we go closer to the North Pole, that on the North Pole, we're gonna see the uh, celestial North Pole on top of our head.
I
And
see.
if we're gonna go to the equator, we're gonna see we may not able to see it. It's very close to the horizon. That kind of imagination, I gonna show. I have some material prepared for that. I'm gonna show it to you later on, probably next week, and hopefully, with help of the John, we can create some cheat sheets about this kind of basic information and also
Thanks.
sharing tips. Hopefully helpful.
Thanks.
Any question? Think we passed about I think another hour of our session. If you had any question,
Hey,
please.
thanks everybody tonight too. Great questions, good discussion. I really enjoyed this a lot. I hope you did too.
Thank you. Yeah, this thing definitely. Yes, yes.
Thank you, everyone, and hopefully I have your excitement times working for the Skynet, and also going forward to the next weeks and the next enjoyment on the other section. But my promise for you, by the next week, we're gonna have some basic kind of learning tool on the astronomy and also measurement and that coordinate system. It's very handy and kind of very simple way. Hopefully, if you get used to it in the next weeks, that's gonna be easily absorbed in right order. Hopefully.
Thank
If
you very
anybody
much. Appreciate it.
Any problems making any observations of these planets and things at this point, do reach out and let us know.
Thank you.
Thanks.
And any question?
Good night.
Night, everybody.
Mohammed, I see you just talking. I didn't hear you. You mute.
You're mute.
Yeah, no, I said thank you very much for,
Sorry, I
yeah.
got some picture from Jupiter and Moon. What should I do from now to the next week with them? It's like, it was good picture actually, I thought.
But the procedure that we showed to you today about the AfterGlow,
Oh,
you,
okay.
you
Yeah.
have to go to the AfterGlow and maneuver with the object,
Mhm.
zoom it in, zoom it out, and things like that. And next week, we're gonna show you how you're gonna submit it on the web assign based on the procedure that we have for the class.
Thank you very much.
You're welcome.
Thank
Thank
I
you,
also just got a
everyone.
picture.
Thank
And
you.
hope you
Thanks.
have a great night.
Thanks.
too.
And see you
Thanks.
next week.
See you next week. Thank you.
Thanks. Bye, everyone. Bye.
Thank you.
Yeah.
Bye bye.